5.4 solutions. Dotted my I twice. And applications of right triangles. So basically, we're going to be using sine, cosine, and tangent to find the side lengths of some triangles that we know are right triangles. So obviously, we've kind of been dealing with right triangles along the way. We'll have different ways of solving triangles depending on if they're right triangles or something else, but the other options come in, I think, Chapter 7. We'll have a law of sines and law of cosines to solve all the lovely things like side, angle, side, angle, side, angle, angle, side, all those, luxurious things. But we have a little while before we get to that. So these problems, they want us to solve the triangle. So starting with one where they actually give you the triangle, just for reference. Let's see, number 16. So they give us a right triangle drawn like this. And hopefully you remember from geometry, but the little box in the corner indicates to you that it's a right triangle. This is X, this is Z, and this is Y. And they use different letters depending on the problem. When we get to the ones where we're setting up the triangle ourselves, they'll just be using A, B, and C. But for these ones, they rotate between X, Y, and Z, and A, B, and C. Why, I don't know. And so then this is side Y, this is side X. They tell us that this angle down here is 47.8 degrees, and this side length up here, which happens to be side Z, is 89.6 centimeters. So ultimately, our goal with this stuff will be to be able to solve some very basic trig word problems. One of the ones we do in pre-cal is there's like a tower in Yellowstone, and it's a fire tower, so it's the park ranger sitting there, and she can spot a fire so many, miles away or whatever, and she's approximating where it is based on the angle that she's at, and to help them so she can call it in and be like, hey, we need to go put out this fire, blah, blah, blah. Anyways, things like that we'll be able to do with these basic applications of right triangles. So they want us to find basically the missing pieces of the triangle. So we already know what I like to do is I like to set up everything that I'm trying to solve for. So X, Y, and Z as angles. So I know angle Z is 90 degrees. Angle X, they told me, was 47.8 degrees. Then the side lengths, which are lowercase letters. So uppercase letters are angles, lowercase letters are side lengths, and obviously in some cases it's hard to tell the difference between the upper and the lower. That's why I like A, B, and C. Well, C is kind of hard to tell, but X, Y, and Z, they all kind of look the same. So just kind of have to, but make sure wherever your angles are, you put the little degree symbol on them. So the easiest thing to find, I guess I should put Z, we also know, is 89.6 centimeters. There we go. The easiest thing to find first is going to be that third angle. How many degrees are in a triangle?
360.
That's a circle.
180.
Yes, 180. So to find angle Y, I can do 180 minus the other two angles, so minus 90 and minus 47.8. Which gives us 42.2 degrees. So I put that in up there. Then for side X and Y, I'm going to use basic sine, cosine, and tangent, and you're going to use your calculator to type them in to solve for them. Now, your calculator, I don't remember, because like I said, I teach trig in multiple classes. I don't remember if we talked about this, but your calculator has modes. It has a radian mode and a degree mode. So you need to make sure that your calculator's in degree mode or your answers are going to be wrong. So we'll talk about that when I pull up the calculator here in just a second. But if I want to solve for x, and the only side length that I have is z, which is over here, the hypotenuse, what trig function, sine, cosine, or tangent, does an opposite value and a hypotenuse value?
Sine.
Yep, sine. So this is going to be the sine of 47.8 degrees is equal to opposite, so x over hypotenuse of 89.6. And then to get x by itself, I multiply both sides by 89.6. So I'll have 89.6 times the sine of 47.8. So I'm going to show you, if you have a calculator that's like brand new, it probably is automatically set in degree mode. If you're borrowing one, or it's like one that was a sibling's, or you bought off eBay or something like that, may or may not be in this setting. So we're going to go up here to mode, which is at the top of your calculator, and we're going to go down. You're going to see this radian, and you're going to see degree. So right here, this third option. You need it in degree mode. So if it's currently already lit up as degrees, then you don't need to do anything. But as we go, so more so next chapter, we'll get into radians more. And so you'll sometimes have to flip back and forth between radian and degree mode. So just always check what your calculator's in, because it would be super unfortunate to get a problem wrong on the test because your calculator's in the wrong mode. So just make sure you pay attention to that. Once you know that you're in degree mode, you can just hit second mode and it gets you out of it. It quits. So then now I just do 89.6 times the sine of 47.8 and hit enter. And so this side length, and we'll just do one decimal place on these, is 66.4 since it'll be rounded. So when I put it up here in my little table of stuff to make sure I have everything solved for, we're going to want to put those units on there since they gave us units. If they don't give you units, you don't need to worry about it, but if they do, you should put them on there. Not the end of the world if you don't, but just to get in the habit. Now, at this point, we know it's a right triangle, so I have a couple options. I can use the Pythagorean theorem, or I can use another trig function. For the sake of us getting used to it, I know y'all know the Pythagorean theorem. I'm going to make sure that we know how to use trig functions. So I'm going to use another trig function. So what trig function can I use to associate y with another trig function? Or not with another trig, with another one of these side lengths, sorry. Yeah, so what trig function associates side y with either x or with z? You can choose either one. I usually will use the given information, because if I did something mathematically wrong in solving for x, and then I use that to help me solve for y, then my answer is probably going to be wrong for both. If I use given information, I have a better chance of at least one of them being right if I did something wrong. So let's do this. What trig function would associate this adjacent with the hypotenuse here?
Cosine.
Yep, cosine. So we'll set it up basically the exact same way. So we'll have the cosine of 47.8 degrees is equal to this adjacent y over hypotenuse 89.6 centimeters. And then we'll multiply there. So I'll have 89.6 times the cosine of 47.8. So then I just type that in, 89.6 times the cosine of 47.8. And to one decimal place, I get 60.2. So then 60.2 centimeters. And then the other thing that hopefully, I don't think we talked about this before, maybe briefly, but just as a refresher from geometry, hopefully, that your smallest angle should have your smallest side, and your biggest angle should have your biggest side. If not, that should be a clue to you that something is wrong. So, anyways, the bell's about to ring in like 2 minutes, so I feel like this class flew by. Anyways, that's okay. So we'll finish this up tomorrow. Tentatively just plan for a test on Tuesday, but we'll see where we get to tomorrow and how much time is left once we do these and go through those couple word problems as well. So I want to make sure that, we're good to go before we take the test, since it'll probably be the last big thing on this quarter. So we may bump it to Wednesday, but plan for Tuesday, and if we bump it to Wednesday, you just get an extra day.